Alright, so for this one we're going to need to draw a pedigree on number 11. So we're going to start with Karen and Steve, and we know some information about them. So here's Karen and Steve, nice couple. So Karen and Steve each have a sibling with sickle cell disease. So that means Karen and Steve both have parents and siblings. Well, that's great to know. So there's Karen's dad, Karen's mom, Steve's dad, and Steve's mom. Okay, neither Karen nor Steve nor any of their parents have the disease, and none of them has been tested to reveal sickle cell trait. Based on this incomplete information, calculate probability. So we want to know the probability that they're going to have an affected child with sickle cell disease. Now, we don't know specifically that this is a dominant or recessive trait. Now, we can figure that out here, though, because we know that their parents did not have the disease, but they had a sibling. Now, I don't know if that sibling was male or female, so I'm going to put them little diamonds, and I'm going to color them in, that each had sickle cell. All right. So that means that these that are affected, are little a. Karen, Steve both have a big A. Each of their parents each have a big A. Now, since they both have siblings that have the disorder, that means their parents have to both be heterozygous. Now, we do not know if Karen is a big little or a big big. We do not know if Steve is a big little or a big big. So we're going to look at Karen's parents. So we're going to start with Karen here. So her mom is big A. Her dad is big A. Big little. So these are all the things that Karen could have been. But we know of all these things, she is not this guy right here. She's not little a. So she has three options. So the probability of her being a carrier, so Karen as carrier, is 2/3. So that would have to happen first. If they're going to have an affected child, then that means that Karen has a 2/3 chance of being a carrier. Well, the same thing's going to happen there with Steve. Steve has a 2/3 chance of being a carrier also. Steve, 2/3. And now we take the roll and assume that they did receive it, because we're going to include this in our probabilities. So that would make Karen big little and Steve big little. So Karen crossed with Steve, big little, big little. For them to have an affected child is this little 1/4 down here on the bottom. So we have three different events that have to occur. Karen has to be a carrier. Steve has to be a carrier, and then they would they would pass that on to their child. So our probability that's going to be 4 out of 936, 4, which is going to be 1/9. Very nice, very nice.